Okie dokie. Can you guys hear me again?
Yes, we can hear you.
Right. So let's continue on with pricing derivatives. So now we did the call. Let's try to play with the put. Try to play with the put. Try to play with the put. It's going to go a little bit faster now because don't have to go through all the same steps, but one example, we do the put. So here the payoff function is f of x. This is 5 minus x. So again, here's the strike. This is strike K. So we're going to look at the as before, right? We had the stock. It started out with 4, it would go up to 8, down to 2. We had the bank, it would go from 1 to 1.25. And now we're interested in the put. Now we're interested in the put. So the put will have, we'll have to put 8 into this function now. So this will be f of 8, and this is positive part. F of 8 would be minus 3 positive part. So that will now be a 0. And f of 2 would be 5 minus 2. That would be 3 positive part. That's equal to 3. Okay, and so the big question is, what to put out here? We have the stock, we have the bank, we mix them together. We want to get 0 and 3. Okay, and the way we get 0 and 3 is by looking at the replicating portfolio. Right, so I know I want to get 0, and I know I want to get 3. In the upstate, I want to get a 0. Okay, so what is the value of my portfolio in the upstate? Well, I'm going to hold this many units of the bank, and the bank's value at time 1 is always 1.25. And I'm going to hold delta units of the stock. The stock always ends up being 8, not always, the stock ends up being 8 in the upstate. So this is 8 times delta. I want that to be my 0. And likewise, in the downstate, the bank account always goes to 1.25. So that's what I have down here. And then the stock in that case is just going to be worth 2. So I'm going to get delta times 2. And these two here are my replicating equations, and the replicating portfolio is going to be the solution of this. So I need to solve to get and what is convenient now is that we already have the software built. So if I switch it up and I go to Mathematica, this one here was our code from before the break. Clean up a little bit. So what has changed? The only thing that has changed is the right-hand side. I'll now have a 0 here in my first equation, and I'll have a 3 in my bottom equation. This is what changed. The rest is the same. Like the left-hand side, the value of my portfolio in the up and the value of the portfolio in the down, this remains exactly the same. I'll go ahead and solve. And I'm going to get delta naught. This is 3.2. And I get that delta is minus a half. Okay, and then I go on to price. To price, I need to take the 3.2 times the value of the bank account times 0. This is a 1. And then I need minus a half times the value of the stock at time 1, that was 4. This is going to be the price of my put at time 0, and this is 1.2. And then I go back. I can now fill in the question mark. This is going to give me what the question mark is. This here is delta naught times 1 plus delta times 4. This was equal to 3.2 plus minus a half times 4. And this was equal to, what was it we got? Was it, what was it we got? We got 1.2. Any questions about the put? The last one I want to do is I want to do the forward. I want to do the forward, and so for the long forward, we're going to have that this here is x minus, say, 5. And we had the same pictures before. We need to look at, so we have the stock. This was 4, 8, 2. The bank was 1.25. And we need to look at the forward. Forward will be 8 minus 6. So this will be 8, no, not minus 6, minus 5. This will be a 3. And downstairs it will be 8 minus a 2. That will be a 5. This was all wrong. Aha, this was all wrong. The down price was 2. 2 minus 5. This is minus 3. Minus 3. Sorry. There you go. 2 minus 5. 2 minus 5 minus 3. And the question is, what is out there? And remember, if this question mark happens to be 0, then k equal to 5 is the forward price. Okay, you set up the replicating portfolio just as before. We'll have my investment in the bank times 1.25 plus the investment in the stock in the upstate. That's going to be delta times 8. I want this to be 3. I want the other one in the downstate, always getting 1.25 out of the bank. In the downstate, I'm going to get delta times 2. I want that to be minus 3. I solve, and what is the solution? Okay, I go back to my Mathematica code. Instead of a 0 here, and I want to put a 3. Instead of a 3 here, I want to put a minus 3. And I solve. It's going to give me delta naught is minus 4. And it's going to give me delta is equal to 1. So then I go figure out what the price is. So this is -4 times 1 plus 1 times 4. This is a 0, it's the forward price. This here will give me a 0. Therefore, that particular strike is the forward price. The forward price of this in this model here is 5. Any questions on the forward? So you can see, for example, if I took K to be 6, this would not have a 0 value at time 0. Like what would change? What would change is that I'll have 8 minus 6, so that will give me a 2. And I'll have 2 minus 6, this will give me -4. All right, so here I would have, in this case, I would have, what would I have? I have 8 minus 6, so that would be a 2. And I'll have 2 minus 6, that will be a -4. What is the value of this payoff at time 0? Well, I'll go back to my Mathematica code and redo the calculation. I'll go back, when instead of 3 here, I want to put a 2. Instead of -3, I want to put a -4. I go ahead and I solve, and I get -4.8. That's going to be my position in the bank. And the other one stays the same. That's still a 1. I solve, I get -0.8. So this is -0.8. And so because that is not 0, that is not 0, that means that this 6 here, this is not the forward price. So 6 is not the forward price. Are there any questions and comments on this part? So the left-hand sides of the equations, this is the same. And the right-hand side, this changes depending on what derivative you're looking at. Are there any questions or comments before we move on to something else? I put a question on the next homework where you're being asked to perform these calculations just with some different numbers. If there are no questions, then we'll move on to One thing that comes up a lot, and I've seen this come up both in textbooks, I've seen it come up in job interviews. So let me try to show you. It's basically just a trick. It's one way to approach a complicated problem, but one thing that often comes up is combining pictures to solve problems. Okay, so this is very loose. I get that, but it really does come up in different contexts. Let me try to give you an example. So there's something called put call parity. There's something called put call parity. So if you look at the put, right? So the put picture looks like this. And the calls picture looks like this. So now you could be interested in combining them. So what is meant here? Combining pictures to solve problems. Okay, so if I combine these two pictures, if I say, so take, if I take a minus sign on this one and I add it together with this one, so if I do minus plus this picture, what would I get? Well, I'll take minus this picture plus this picture. Okay, so the way to do that, and this is what the trick is, the way that you work with these graphs is, so the recommended way of doing that is that you start out here. You start out in this direction, you start out here, and then you move that direction. You start as far out to the right as you can, and then you go to the left. Okay, so why do I do that? Well, look at these pictures here. This one here all the way out to the right is just a 0. Okay, so when I combine these two pictures, I just need this slope up here. Okay, so nothing is happening until this thing, until the slope goes down, right? So you could have, so what you would get is you would have this picture up until K. And then what happens is that now this thing flattens out and this thing here moves. So this thing here now becomes down here, right? Because it has a minus sign. So this thing flips over. Okay, so, and this one stays flat at 0. So what happens now is that this thing is going to go down and you're going to continue going like this. Actually, I take this picture with a minus sign, this picture here with a plus sign, I add them together, I get this thing. That looks familiar, right? This here is exactly x minus k. This is the forward. This is the forward pair. So you see what is happening now is the forward is going to be equal to, what is going to be equal to? It's going to be equal to the call minus the put, right? So you're going to get the pull call parity just by looking at these pictures here. You're going to get that the call is equal to the forward plus the put. Does that make sense? This is the put call parity. I can express the call price in terms of the forward price plus the put price, right? And in our example, we had the call was 1.2. We had that the forward, we actually found that the forward price was equal to 0. Well, then this equation here is going to dictate that the put price must also be 1.2. And we're good. So the difference between put and call prices is exactly the forward. So I have seen problems like this one come up in various contexts. So maybe just to give you something to practice on, one could do, this here is an old interview question, like create a payoff that looks like this. So it's 0, 0, 0, and then at 1, it goes up like that to 2, and it comes down like that to 3. I create this payoff from puts and calls. Like how many puts are you going to buy at what strikes? How many calls are you going to be buying and selling at what strikes to create this particular payoff? So try to create this payoff from puts and calls. So you need to buy, you need to sell at various strikes. Okay. How would you create this little hump here? So you zero outside, and then in between you have this this particular payoff.
Wouldn't you just, you'd be long calls and puts at 3 and 1, and then short a call and a put at 2. So sell 2 at the money and then buy the wings.
So I'm not going to walk you through the solution. I want you guys to try to think about it, see if you can get it to work. Try to see the way that your thought process is. Do you start, when you start solving this using other diagrams, do you start out here? Do you start in here? Do you just start in the middle? What is your thought process? And as I said, my recommendation is to start way out here to the right. And I won't take you through the solution here, but I hope you can get a sense of like, what do you need to do? You need to buy and sell calls at various strikes, right? So there's going to be something with strike 1, strike 2, and strike 3. You're going to be buying and selling puts and calls at these 3 strikes. How many do I need to buy at the various strikes? So this is a typical question that you can solve using these pictures. And there's endless variations, right? I could make it flat up here and then have it come down, or I could have it go down and then come back up and go down. Like you can have all kinds of payoffs. And instead of trying to solve them using equations, maybe it can be helpful to try to solve them using these diagrams. That's all I'm saying. Okay, so try to think about this, and then I'm not saying that your approach is wrong or right. I'm just, I don't want to walk you through it here in class. Just try to think about it. If you can you generate such a payoff here using puts and calls? Okay, so we have a little bit of time left. And the thing that I want to spend the last time talking about is something that is, I know this is confusing, and we have even made a point out of it here in the very beginning of today. We made a point out about this random variable psi here. See, there was no specification of p. P never appeared anywhere. We even wrote it explicitly. Somewhere. Find the place where we wrote it explicitly. We wrote it explicitly here that there is no p. In these examples that we've calculated, there is no p. We do not specify what p is. And yet, here we come, and there's something called risk-neutral probabilities. And these can be confusing, in particular in the beginning. So there's a concept called risk-neutral probabilities. So this is a new concept. So, while P, and sometimes the other one, this is 1 minus P, they are not relevant. While these two guys are not relevant, the risk neutral guys, the risk neutral analogs, denoted by P tilde, and then yes, this is Q tilde. These ones are relevant. Right, so we don't see P's anywhere, but we're going to see a lot of P tildes and a lot of Q tildes. They appear everywhere. So let me try to show you how to calculate these risk neutral probabilities. So the way that I propose that we go about doing business is to create, we're going to create these infamous securities called Aero-Dibra. These infamous Aero-Dibra securities. So how do we go about doing that? Well, the way we're going to go about doing it is we're going to have our model. We're going to have our stock. So it goes from S0 up to S0 times U, and then S0 times D, right? Our S1, this here is this is S1. So it's nothing else than S0 times this random variable psi. And then we have the bank. And the bank only has one payoff, not two. This was the one that goes from 1 to 1 plus R. Okay, so to create the Aero-Dibra securities, first order of business is multiply both sides by S0. Okay, so I'm going to multiply here by S0. I'm going to multiply here by S0. And then I'm going to divide. I'm going to divide. So I'm going to divide this, the left-hand side, I'm going to divide by the right-hand side. And divide, so I'm going to get the discounted stock. The discounted stock. So discounted means I'm dividing. So this is going to be S. There's going to be S0. This is going to be with a tilde on top. So it's going to be S0. Maybe I don't want to multiply by S0 here. Let's keep it like that. This is just going to be S0. And then the other one is S01. This is going to be equal to S1. That's this guy. Divided by 1 plus R. And likewise, if I divide through here by R, now I'm going to eliminate the slope on the bank account. So I'm going to get a discounted stock and discounted bond. The discounted bond, this is just going to be, well, it'll be 1, and it'll be 1 plus R, and then divided by 1 plus R. This is also a 1. So what I'm doing here is in the discounted market, these lines, the line on the bank account is just going to be flat. It'll be $1 here, and it'll be $1 over here. The stock is going to be different. This is going to be, initially, it's going to be S0. And then at the end, it's going to be S0 times U divided by 1 plus R. It's going to be S0 times D divided by 1 plus R. These are my discounted prices. I discount the stock by the bank, and I'm going to get a new set of prices down here. And the only thing I did was I leveled out the line for the bank account. It just became flat. Okay, so first order of business is to create these Aero-Dibra securities. Aero-Dibra securities, this is about trading. This is about trading right here now in this discounted stock and bank, and to create payoffs that are very simple. The payoffs that we're going to create will be these 0, 1 and 1, 0 and 0, 1. This one here is called the up. This is the up algebra. This one here is the down. Okay, so let's go back in the example and let's try to do it in the example. In the example we would have 4, and then we would have 8, and we would have 2. This was the stock. And then we have the bank. This would be 1, 1.25. This was the bank. And now we look at the discounted stock. We look at the discounted bank. So what I need to do is I need to divide 4 by 1. Okay, so that's still going to be a 4. But the other values here will be 8 divided by 1.25. And this here is 6.4. The other one is 2 divided by 1.25. And this is equal to 1.6. And the bank is just going to be 1, and it'll be 1.25 divided by 1.25, which is of course equal to 1. So these are my discounted securities. These are the undiscounted ones. And what I want to do is I want to trade in the discounted stock and in the discounted bank to create these payoffs 1, 0 and 0, 1. This is how we create these algebra securities that we're going to be using quite a bit. So let's try to put down the replicating portfolio. Right, so the replicating portfolio, what I want to have is the payoff. What I'm going to have is a payoff of 1 and 0. And the value of this thing here, I'm going to call P tilde. And I want to set up the portfolio. Okay, so I'm going to be investing delta naught in the bank. Okay, so that has terminal value 1. And I'm going to be investing delta in this one. In the upstate, delta comes out to 6.4. Delta times 6.4, I want that to be 1. And in the downstate, I still am at a 1 over here, and then it'll be delta times 1.6. And I want that to be 0. Okay, I solve. So let's switch over to Mathematica and solve these two equations. Okay, so what am I having now here is there's no interest on the bank account. Instead of 8 here, it's 6.4, and I want this to be 1. Likewise, in the downstate, there is no interest, and the value of the stock in the downstate was 2 divided by 1.25. This is 1.6, and I want a 0. I go ahead and I solve these. I'm going to get the investment in the bank account. This is minus 0.33. And the investment in the stock, this is 0.20833. And I can now create the price. This here is my pricing formula. So I need to take the solution. Delta naught is this guy. That's what I invest in the bank. The bank's initial value is 1. This here is how much I invest in the stock. The discounted stock was worth this much. I create it, I get a half. Okay, so I'll report the initial value. P here, this is equal to minus 0.333 times 1 plus my delta. This was 0.20833 times the initial price of the stock. The initial price of the stock was 4. 4 here. I plug it in, this is equal to a half. And this is denoted by P tilde. P tilde is equal to a half. So that's one error diverse security. The other one I'm interested in is when I swap 1 and 0. That's what I'm going to call Q tilde. So here I'm going to put a 0 and I'm going to put a 1. I'm going to resolve my equations. And the only thing that's going to change is I'm going to alter 0 and 1 here. So I'm going to get 6.4. This should be 0. And delta naught plus delta 1.6. This is a 0. I'll solve. Back to Mathematica. So here, instead of a 1, I'll put a 0. Instead of a 0, I'll put a 1. I'll solve. I'll get 1.33. Get 1.33, and I get delta. This is minus 0.20833. And now I'll stick it into the formula down here. Solve, and I get half. Q tilde is also equal to a half. Okay, so Q tilde is equal to half, P tilde is equal to a half, and you can see it necessarily has to be, it must always be that P tilde plus Q tilde is equal to 1. And why is that? Well, because if I take the two payoffs, if I take this payoff and that payoff, because if I'm looking at the payoff that has 1 and 1 here, right, that the price of this thing, this is going to be exactly P tilde plus Q tilde. But I compare it, now I'll have 1 here and I'll have 1 here. This is exactly the bank. Because the bank, exactly the bank, I always end up with a 1 here. So there's no difference between this payoff here, 1 and 1. This is the discounted bank. There's no difference between the discounted bank's payoff and the portfolio of these two diverse securities. So therefore, the bank has the initial value 1. So therefore, this one here also has to have the value 1. So it's always enough just to compute one of the two. You don't have to go through the second step here. As soon as you compute what P tilde is, you get Q tilde by subtracting P tilde away from 1. The half, this is not always the case. P tilde and Q tilde could very well be different than a half, but they must always sum to 1. Right, so it could be 0.2 and 0.8. It could be 0.8 and 0.2. So these are the error diverse securities, and the reason that they are so effective is that you can very easily compute these derivative prices. They basically work like a basis. So error diverse securities, these securities. So here it's 1, 0 and 0, 1. They are similar to a basis. For R2, right? So if you go back to the example, of a, if you go back to the example of a put, so the put from before, you would have the payoff would be 5 minus X positive part. It would be 5 minus the stock price. And what we will be interested in is we want a replicating portfolio. So we want a replicating. So we want delta naught times 1 plus R plus the investment in the bank. This was an investment plus the investment in the stock. So this was S1. We want this to be equal to 5 minus S1, positive part. And here's how it comes in handy. This is my equation. I will then just divide through by 1 plus R. I will discount. This will be delta, and then it will be S1 divided by 1 plus R. And this is equal to 1 plus R, 5 minus S1, positive part. And this here was my discounted stock. This here was my S tilde 1. So I need to solve here. I have two equations because S1, there's a U factor and a D factor. Depending on what psi is, there will be two equations here. S1 can have two possible values. But if you look at the right-hand side, what will all this mess here be? Well, it'll be the discounted payoff. This is the discounted payoff for the derivative. And so what will be in our example, this would be 1 divided by 1.25 times 5 minus the stock price in the upstate was 8. So this is 5 minus 8. Positive part, this is a 0. In the downstate is 1.25 times 5 minus, and then it's a 2, positive part. So this is a 3. This is 3 divided by 1.25. And so what we have now is, this is the payoff, and this is where it comes in to be like a basis. Because what do I need to buy? If I buy these two securities that we constructed, they pay out 1 and 0, and 0 and 1. So if I want to create this payoff, I should buy 0 up, and by how many of the down ones should I buy? Well, the down ones, they have a payoff of 1. So I should buy 3 divided by 1.25 down. Well, this is going to cost me, I don't buy any ups. The up ones was do a price at a half. And how much of the price, what is the price of the down ones? This is also a half. And so the price is going to be times 0 price is going to be half times 3 divided by 1.25. And voila, this is exactly what it's supposed to be, 1.2, which is what we had already figured out earlier. So using these error-diverse securities, it becomes much simpler. If you have them, it becomes much simpler to price derivatives. You just look at the payoff, and then you buy that payoff, that number that you have here. This is how many of the up ones you have to buy. This payoff you have down here, this is how many of the down ones you have to buy. And then you know what the prices are. This quantity here, this was my Q. This one here was the Q tilde. So that's the price. This is how many you need. Multiply them together, and you're going to get the price that comes in. Okay. Are there questions about these slides here? Any questions about what we've been talking about tonight?
Professor, so you're saying the basis of the payoffs were the original 1, 0 and 0, 1, and then from that we figure out how much we need to buy.
Yes.
Or of each. Okay.
Just imagine that. So let me try to elaborate on that. So say you want to price this payoff. You have 17 and you have 8. Just random numbers, and you know the price, you know the algebra prices. These are just called 80. So you know that this here is a 1, and this one here is a 0. This is P tilde. And you know this is 0, and this is 1, and this is Q tilde. And you want to price this one. Okay, so the first order of business is this here happens in the discounted market. So the first thing you need to do is to move the payoff into the discounted market. And the way you do that is by dividing by 1 plus R, which in our example was like 17 divided by what was 1.25. And this one here, so that's the first thing you need to do. 8 divided by 1.25. Okay, so you can trade in these two now. How many of these two should you be buying / selling to create this payoff here? Well, how many of this one do you want to buy? Like this one here is the up. This one here is the down. How many should we buy of the up?
That'd be 17 over 1.2.
And how many should we buy of ups? And should we buy or sell the downs? It comes with a plus, so we're going to be buying. How many do you want to buy of the downs? Well, 8 divided by 1.25 of downs. And what's the price? Well, what does it cost to buy 1 up? It costs P tilde. And what does it cost to buy 1 down? It costs Q tilde. So the price at time 0 will be P tilde times 17 divided by 1 plus 2.5 plus you're going to be paying Q tilde times 8 divided by 1.25. This number is what is going to be over here. This is going to be P tilde times 17 divided by 1.25 plus Q tilde times 8 divided by 1.25. So if you have these algebra securities available, you can very quickly figure out what the price is. Does that make sense?
Yes, thank you.
Yep. Other questions, comments?
I have a quick question.
Yep.
So that price that we just found, that's in the discounted market. So to find like the price of whatever derivative, would you multiply like that equation by 1.25?
No. This is already taken into account because, right, this here is the replicating portfolio in the, this is not the discounted. This is the original. But you see, I am replicating in the original model if and only if I'm replicating in the discounted one.
Okay. Okay, thank you.
Then keep in mind when we're discounting in this setting here is this number we have out here. This is a 1. So the bank starts at 1. So when I'm not, the original prices I have out here, I'm not dividing by any new number. These numbers here, whether I am in the original market or in the discounted market, these are the same. If I would have started this thing here out at like 0.1, so 1.1, then I could see that might be a problem that you'd have to take into account, but not here. The initial values of the discounted prices are the same as the initial values of the undiscounted prices. This 4 here and that 4 here, the same. This one here and this one here, they're the same. That's a good question. Questions or comments? If not, I think this is a good place for us to call it quits. I know some of you are, this is very late for you guys, and I think it's a good place to stop. Next time, we will do a little bit more about this risk neutral pricing, and then we're going to go back into Hull, Hull's chapter 4. We will talk about interest rates in there for a little while. Otherwise, there is homework due, and we also have office hours, both the TA and I, on Wednesday and Thursday and Friday. Okay, if there are no more questions, I'm going to turn the camera off, and have a good night, guys.
Thank you.
You're welcome.